So this question says the velocity of a particle in a fluid is dependent on pressure and density. Consider an object of mass m depending on the stated quantities. Find an equation of the velocity of the particle. So we have been given, or we have been told to say the velocity of a particle in a fluid is dependent on what? So they're saying the velocity is dependent on, so I'm going to put k here to represent any number. Yeah, so I'm going to put k there to represent any number. So they're saying it's dependent on the pressure and the density. Consider an object of mass m depending on the stated quantities. Find the equation of the velocity of a particle. So I'm going to put x and y there. So my m here will be to find the values of x and y. So what are the dimensions for velocity? The dimensions for velocity are, we know that velocity is given by mass, meters per second. So meters per second, this implies that we have the meters there, that's the length, the what? The second. Second is time. So, okay, here I'll just be writing the final dimensions. So let me derive it from here. So we have meters there, which is the length, over the second, it's time. So we can write this as L t to the power -1. So we have L t to the power -1 and m to the power 0. Then we say this is equal to, we have k, open brackets. Let us derive the dimensions for pressure. So we know that pressure is equal to the force applied on a perpendicular area. So we have the force. So the dimensions for force, we said it's what? It's mass and L t -2. This is what we found, right? And area is simply just L2. So pressure, the dimensions for pressure will therefore be, the dimensions for pressure will therefore be m, L, L to the power what? So we're going to have L times L to the power -2. Then we have T to the power -2. So the pressure will be M, the dimensions for pressure. So when you are representing dimensions, you have to write it like this. So the dimensions for pressure there, we're going to have L to the power 1. So this is just subtracting the numerator. So 1 minus 2, we're getting L to the power -1. Then we have T to the power -2. So that is what you, this is what you get as the dimensions for what? For pressure. So we put the dimensions for pressure there. So we have M, we have L -1, we have T -2. Then we put our X there. So we put the power there. So we're multiplying this by the dimensions for density. So let us also derive the dimensions for density. So we know to say the density is simply just the mass over the volume. So density is equal to the mass over volume. So the dimensions for mass is capital letter M, and the dimensions for, okay, so even this was supposed to be like that. I don't know why I'm forgetting to put this. So the dimensions for density will therefore be the capital letter M there for mass, and then divided by the volume, which will just be L to the power 3. So this will therefore be M L to the power negative 3. So these are the dimensions for density. So density, we put m, then L to the power negative 3, and we also have T to the power 0. So now we can compare the powers, or before you can compare the powers, if you want, you can first open the brackets by distributing the x and the y there. So this side, anyway, let us just open the brackets just from here. Or maybe it's for better understanding, let me open the brackets. So this side we're going to have L T negative 1 m to the power 0. And we say this is equal to, then we have k, then we have m to the power x, and then this L to the power negative x, then we have t to the power negative 2x. And then in the other set of brackets there, we have m to the power y, t to the power, L to the power negative 3y, and t to the power 0. So now we compare the powers. So we start with the powers of L. The powers of L, we have this side, the power of L is 1, and we say this is equal to, the power of L here is negative x, the power of L there is negative 3y. We check the powers of t. So the power of t here we have negative 1, the power of t there we have negative 2x. Then the power of t there we have what? We have 0. Okay. Let us move on to the powers of m. So the power of m this side we have 0, and then we say this is equal to the power of m there we have x, then the power of m there we have y. Okay. So we can now start finding the values of x and y. So what you can do here, you get the simplest equation, which I believe in this case is this one. So I'm going to get negative 1 is equal to negative 2x. And then if I divide by negative 2, the value of x becomes 1 over 2. So I found the value of x. So after finding the value of x there, you can now move on to finding the value of y. So to find the value of y, you simply just have to find the value of y, simply just have to get another one of these remaining equations here. So I can even get the first one. If I get the first one, I'm going to have 1 is equal to negative x minus 3y. So while is x, I'm going to put 1 over 2. So I'm going to have 1 is equal to negative 1 over 2 minus 3y. So this 1 over 2 cross the equal sign, and I'm going to have 1 over 2, this will be 1 plus 1 over 2 being equal to negative 3y. So when I add this, I'm going to get 3 over 2 being equal to negative 3y. If I divide by negative 3 on both sides, I'm going to get my y as a negative 1 over 2. So this means this same answer that you have gotten here is the same answer that you are also going to get if you use this one. Let's try to use that. So if we use this one, we know that if we take this x to the other side of the equal sign, it's going to be y is equal to negative x. And then the value of x we found was half. So the value of y will therefore be negative, while this x we put half. So this would be negative half. You can see that the answer that we found there is the same answer that we're going to find there. Yeah, so we have found the values of x and y. So we just have to replace them there to get the equation we're looking for. So the equation will therefore be V is equal to K, and then we have the pressure raised to the power what? X. So the value of x is half, and then the pressure, the density is raised to the power negative half. So we put that. Then we can simplify this further. So the velocity is therefore equal to K. Anything raised to the power half means the square root. So we have the square root of P, and then this one, to make this half positive, we are also taking it down so that it becomes positive. But because it's also raised to the power half, means that it will go down so that it becomes positive. Or let me just do this for the sake of understanding. So V is equal to, we have P to the power half, and since it's also raised to the power half, means that we're going to have K root P over this one is density, sorry, not P. And then the denominator there will be also the root of rho, which is density. So the final velocity there, therefore, will be K. We combine this, so this will be K root P over rho. So this is the density, rather, this is the velocity that they wanted us to find. Yeah, so this is the formula, this is the equation that the question was asking us to find. So these things are very simple. You just need to take your time bit by bit so that you don't make mistakes when solving. Okay. So we proceed to the next question.